Algebraic shortcut number 1, the base multiplications. This algebraic shortcut uses a special kind of referential multiplication called base multiplication. For example, 29 times 7 equals 203, which allows us to easily obtain all possible products of the multiplicand 29 by multiples of the multiplier 7. This is because of the small quantities present in the product 203 of the base multiplication. Suppose that you want to multiply 29 by 21. First, the amplification factor must be recognized. Since 3 times 7 is 21, the amplification factor is 3. Thus, the product 203 of the base multiplication is accordingly multiplied by 3 to obtain 609. The quantities are split in 2 blocks for a more efficient calculation. Now multiply 29 by 84. The amplification factor is recognized as 12, since 12 times 7 is 84. The product 203 of the base multiplication is split in 2 blocks, performing the following calculations. 12 times 2 equals 24, and 12 times 3 equals 36. Hence, the result is 2,436. This algebraic shortcut allows us to obtain the products of multiplying 29 by any multiple of 7. But in this example, 13 is not a multiple of 7. This case must be solved using another algebraic shortcut. Starting from the base multiplication 67 times 3 equals 201, we can obtain the products of the number 67 when it's multiplied by any multiple of 3, doing the calculations with very small quantities. These products follow an easily recognizable pattern when split in 2 blocks of 2 digits, red and yellow colored. Multiplying 67 and 96 is done by referring to the base multiplication 67 times 3 equals 201. Here the amplification factor is recognized as 32, since 32 times 3 is 96. The product 201 of the base multiplication is then split in 2 blocks, performing the following calculations. 32 times 2 equals 64, and 32 times 1 equals 32. Hence, the result is 6,432. With the base multiplication 79 times 9 equals 711, it's easy to obtain all the products of 79 by multiples of 9. These products follow a pattern. They contain a sequence of the multiples of 7 in red and multiples of 11 in yellow. This is an example of applying the base multiplication 79 times 9 equals 711. Where the amplification factor is 8, since 8 times 9 is 72. One more example with the beautiful base multiplication 72 times 7 equals 504. This allows us to obtain all products of 72 by multiples of 7. This is an example of calculating with the base multiplication 72 times 7 equals 504. The amplification factor is 9. One example of a middle block base multiplication. 63 times 17 equals 1071. The middle block, the 2 middle digits of the base product, 07, is to be amplified to calculate the products of the deduced multiplications, marked in red. Another middle block based multiplication, 43 times 27 equals 1161. Note that the multiplicand 43 also can be amplified, obtaining the last three multiplications with multiplicand 86, the double of 43. The middle block 16, marked in red, is to be amplified to calculate the products of the 5 deduced multiplications. An example of calculating with the base of multiplication 43 times 27 equals 1161 is shown. The multiplicand amplification factor is 2, and the multiplier amplification factor is 3. Then the overall amplification factor is 6. This is the list of the base of multiplications to be memorized. The products are split in two blocks of digits, red and yellow colored, to be amplified in the calculations of multiplications whose multiplicand and multiplier are multiples of the multiplicand or multiplier of the corresponding base multiplication. Second part of the list of the base multiplications. Third part of the list of the base multiplications. Fourth part of the list of the base multiplications. Fifth and last part of the list of the base multiplications. Here, the last two columns contain interrelated base multiplications. Remember that the main goal of this course is to develop the full table of 3,321 multiplications of two-digit numbers. Below each multiplication, we will write either the reference or base multiplication, which it is deduced from, or its abbreviated calculation. Next, we write the code of the respective algebraic shortcut. For example, these are the first 12 entries of the 86 times table in decreasing order. Each table cell contains the multiplication to be remembered. Then we must solve each multiplication, deducing the most appropriate method for its calculation. The table cells are filled up in this way until the entire table is covered. There are no comments for this image. This is a typical table cell corresponding to the algebraic shortcut number 1, using base multiplications. Multiplication calculation in detail and its corresponding table cell. A table cell never contains the detailed calculations, but these calculations are abbreviated or implied instead. The exposition of the first algebraic shortcut, the base multiplications, finally comes to its end. This tool will allow us to cover a good percentage of the entire multiplication table.